Hello and welcome back, everybody, for day 2 of Partners Week. We really appreciate all of you guys joining us today. Yesterday, we had a wonderful round of presentations from our many partners, and we've got a great group of guys in for today as well. As a reminder, Partners Week is an event that we'd like to put on for our members as an opportunity for you guys to see what our various partners have to offer you, their platforms, their demos, their specials, and their availabilities. And so today, we've got a wonderful group of presentations. Before we begin, we'd like to thank all of our partners, especially today's partners, RunSafe Security, Upstream, Vic1, and Block Harbor. I'll give you guys a look at the overall agenda. You can go back to the virtual website page to check out yesterday's presentations and recordings, and I highly encourage all of you guys to submit questions throughout the presentations today. Go back to the virtual booths to see some additional information, and if you're interested in speaking with any of the speakers you see today, you can send them messages over in their virtual booths as well. If you have any questions or any difficulties navigating the system, you can always reach out to the Auto-ISAC team, or if you're interested in following up with any of the presenters that you see today, you can of course reach out to us, and we're happy to make those connections. For today, we're going to be hearing from 4 presentations. We're going to start with our first presenter, Joseph M. Saunders, the founder and CEO of RunSafe Security. He's going to walk us through from provenance to protection, navigating the software supply chain and memory safety and SDV software. And with that, Joe, I'll let you go ahead and take it away.
Thank you, and welcome to everyone in the audience. I have some slides to share, so I'm going to do that now and put that in slideshow presentation mode. So thank you. It's great to be here. And with that said, I do want to talk about navigating the software supply chain and look at risk that puts software-defined vehicles and the software therein at risk, and that is memory safety risk. And so to do that, my goal is to walk through 3 areas that are more about the problem within the software supply chain that puts vehicles at risk, and then talk about a couple aspects of the RunSafe solutions, what we call RunSafe Identify and RunSafe Protect, and how we answer the bell in terms of the problems that exist out there. I also have a couple updates related to things related to ICTS covered vehicle rule that I will work into this presentation, and we can talk about those things in the Q&A as well. So I look forward to a discussion, and I also look forward to sharing this information today. So with that said, I think the scale of the challenge can be looked at in a lot of different ways, and that is that there are upwards to hundreds of millions of lines of code in modern software-defined vehicles. There are we used to say 30 or 40 components on a vehicle that may contain some embedded software. We now see as many as 100 plus. And there are dozens of third-party software suppliers that organizations are navigating, whether that's your autonomous software platform or your infotainment or ECUs and the like. There are just dozens and dozens of suppliers that need to be managed. And when it comes to cybersecurity, that creates complexity. And there's not just tier 1 suppliers. Obviously, it goes deep into tier 2, tier 3, and what have you. So hundreds of millions of lines of code, hundreds of applications, dozens of suppliers. In addition to that, hundreds of open source software components. And with that, we know, in contrast, especially in the past month or so, we have seen that AI tools can find vulnerabilities and develop working software exploits faster than we can patch. And certainly as vehicles get older and there's requirements to support software for upwards of 15, 20, 25 years, AI is presenting an existential kind of threat to the software supply chain and risk and cybersecurity ecosystem. So we have a complex software supply chain within vehicles today. We have AI creating challenges that could undermine the risk within that software, identifying vulnerabilities faster than we can patch, and certainly developing exploits within minutes. There were statistics recently showing that, say, 5 to 8 years ago, it might be months before an exploit is written against a given severe vulnerability. Today, it can be minutes or hours, within days for sure. And so that window from vulnerability identification to ability to develop an exploit and have a working exploit is greatly condensed, that window. And it's very hard then on the flip side to have a solution that can counter the speed in which AI could uncover these vulnerabilities. And the reason that's important is not just the potential for cyber attack, but what it means operationally to have a good system to understand the risk, to understand how to mitigate the risk, understand which vulnerabilities you need to prioritize, and certainly how you maintain software over the long term, especially since we want the software to endure, as I mentioned earlier, 20 to 25 years. And OEMs today are starting to ask for suppliers to support things for 20 to 25 years. So the challenge is, increasing in terms of complexity and speed, and that's put stress on all of our organizations. And so one of the questions is, what's actually in your software? And if you think about the software supply chain, the visibility within the auto industry, with different layers of suppliers, with open source software, it's very difficult to know what's actually in the software code itself. Many software bill of materials solutions today that rely on analyzing a software binary after it's been produced, or simply looking at manifest files, they're missing what actually goes into the binary. The example or the metaphor I like to share is more along the lines of, for example, a baked chocolate cake. We all can bite into a cake and we can devise or derive what we think is in that cake. There's probably some butter, there's probably some chocolate, there's probably some flour, maybe some egg. We don't quite know what the amounts are. We don't know what other ingredients are in there. And so that is what it is like to derive a software bill of materials from the binary itself. It's like biting into the chocolate cake. And so I'll get to this more when we talk about it in the solution side, but a much better approach then to have perfect visibility what's in that cake is have the vantage point of at the build system to see, in the baker's analogy, to see the exact ingredients that are going into the mixing bowl that get produced by the baker himself or herself at the time they're creating the cake. And that's different from the recipe list. The recipe list is what the baker intends to do. But we all know in the world of software, third-party components get pulled in, compilers add in certain files, software owners are excluding certain packages from their builds to minimize attack surface. And so you can't rely on a binary-based SBOM, and you certainly can't just rely on what the intended source code is, because during the build process, things are different. And so with that, knowing what's in your vehicle, it becomes very important to know how your software bill of materials was produced. Then thirdly, the scanning tools to identify CVEs are also challenging. And they can't necessarily trace back to which supplier introduced the vulnerable component in the first place. But also, if you don't have the right raw ingredients, if you don't have the right complete, correct software bill of materials, you could in fact miss some of the vulnerabilities, or you could have false positives and have a number of vulnerabilities in your that you think is in your software binaries, the software images that you produce, when in fact they're false positives and they don't exist in the first place. And so again, it's actually very difficult to know what's in a vehicle. You've got tiered structures of suppliers, you have open source software, you have different versions of software bill of materials that get produced, and then the resulting impact of an incomplete binary or one that has false positives in it can then lead to challenges around identifying which vulnerabilities and where those vulnerabilities or components came from, if in fact you don't have that data when you produce the bill of materials, or if you produce false information. And then we have all heard about the country of origin data. It can often be missing, certainly, and there's a critical gap there for connected vehicles. And of course, this is real-time changing, the country of origin requirements. I think most people who were at the Washington, D.C. event last August, September will recall Elizabeth Cannon presenting from the Department of Commerce around the covered vehicle rules. And the most recent information just from the past couple of days is that there are some updates that may be valuable for anyone listening. And that is that there are general authorizations that are posted on the Department of Commerce site for the covered vehicle requirements for country of origin. And in fact, there's two. The original general authorization, the database, or I say the website, says that is pending review. So there may be some changes coming. And so I think everyone should probably watch, or if you don't know where to watch, certainly feel free to reach out to me and I'll point you in the direction of the website. But also that there are, also then there are a second general authorization, which is getting to an approved supplier registry. And so some people may already have this information. Some people will get this published when it comes out. And with that said, I think it's big news from a covered vehicle perspective, what's going to happen. So I'm very interested myself because it affects who, our customers, and affects, what might be in store for requirements of country of origin in particular. So again, the original general authorization is being modified, so there'll be updates there. And there's a new general authorization 3 that is about to produce approved supplier registry. So I think for two reasons, everyone should want to tune in. But with that said, understanding where that software comes from, understanding the risk in that software, who provides that software, and being in control of that software in light of, wanting to have software last for 25 years, and in light of, risk introduced within a complex supply chain, it is good practice then to still understand all these components that are indicators of risk in your software. So the bottom line is visibility into the true ingredients in your software, getting complete, correct information from all your suppliers, and having a meaningful way then to not chase false positive vulnerabilities, but focus on the ones that might actually be in the software. And then understanding where that software comes from are vitally important for software to endure 20 or 25 years. In addition to just what's in the software, we also know then one of the most common types of vulnerabilities in automotive software is in fact what is called memory safety vulnerabilities. And it can be anywhere from 40% to 70% of vulnerabilities in embedded software, including embedded on automotive platforms. And so these common vulnerabilities include things like buffer overflows, use after free, out of bounds, right, kind of vulnerabilities, and even heap corruption errors or heap corruption vulnerabilities. And they affect different layers of the vehicle. And so we have seen buffer overflows in real-time operating systems. We've seen them in infotainment stacks. We've seen them in ECUs. We've seen use after free vulnerabilities in, C++ middleware and, in adaptive AutoZAR. And these are critical vulnerabilities. Why? Because attackers can leverage buffer overflows or use after free to take control of devices. And they can do that in a way to do things that were not initially intended or are counter to what even the driver wants to do. So it potentially could put passengers at risk. Their safety is at risk. And so memory safety vulnerabilities, again, can be 40 to 70% of vulnerabilities on platforms, and they are especially prominent in automotive code written in C and C++, which is still, a significant amount of code out on auto platforms. And so these are examples of the types of vulnerabilities that put platforms at risk. The problem with them is that static analysis and other tools do a very, very poor job of identifying memory vulnerabilities in there. And so if you look at the complex software supply chain and then look at static analysis in other tools that might put your platforms at risk, they're not necessarily identifying all these vulnerabilities. So if you want your software to last 20 or 25 years and you want to minimize the cost to support that, then there needs to be a better way to identify that risk. And so certainly, I think we are finding that other tools, whether it's penetration testing or other means of identifying risk in software, are great options. And of course, those are potentially labor-intensive options. And so there is room then for AI solutions to enter the fold and perhaps do things that static analysis historically hasn't done for us. And so with that, we are seeing with Mythos and other AI platforms the ability to identify more and more vulnerabilities. And so we are working with organizations who want to understand a more complete view of their platform and the risk associated with it, and have a means to then immediately minimize the effort to mitigate these kinds of vulnerabilities. So there's a software supply chain complexity, and then there's a memory safety crisis. And I emphasize that because it really is becoming crisis level if you think about AI being able to find these vulnerabilities when historically static analysis and other tools had not done a great job of it. So organizations I talk to are experiencing a fear that there will be an increase in vulnerabilities. And part of the fear is that there might be a lot of meaningless vulnerabilities they have to sift through. And the other fear is it might find, latent vulnerabilities like these memory-based ones that had not been addressed previously. And so maybe crisis is the wrong word. I don't want to be alarmist, but certainly it's significant if you combine complex software supply chain with latent risk in software that historically we haven't done a good job of identifying. I believe we're going to see more of that coming from the supply chain and more of that in the code that we have today. So with RunSafe, I'll shift a little bit to our solutions then. With RunSafe, we offer a couple different solutions. We offer the RunSafe Security platform, and the RunSafe Identify platform is a portion of that. So RunSafe Security platform identifies risk, protects code, and then going forward, we'll monitor software. And under RunSafe Identify, that first component, we do offer build time software bill of materials and the ability to identify vulnerabilities in your software based on those software bill of materials. So the build time SBOM is foundational because it allows you to efficiently lead to other information that's out there. And what I mean by that is having a complete and accurate software bill of materials is far better than missing, say, 10 or 20% of the components that might be derived from, you might be lacking if you derive your SBOM from a binary, and certainly would be lacking if you did it from, just analyzing the source code itself. So build time is different. Build time is part of the compilation process, so to speak. If you think of the whole set of build tool chain that includes the compiler and the linker and the steps thereafter, in that linking process, what RunSafe does very efficiently is we see I'll say the raw ingredients go into the binaries as they're getting produced. And another way to say that is we see all the file opens that go into the binary when the linking process occurs. Therefore, we have perfect visibility into each and every library component package that gets ultimately produced into that software image. And this is foundational. It's foundational because if you get that accurate software bill of materials, then you can start linking to true CVEs associated with those components. And you can start linking to, here in the bottom left side, open source license compliance checks. And so if you can link to vulnerabilities, you can link to license checks, and you can have full visibility into the origins of where that software came from, all of a sudden you have a more complete, more correct software bill of materials and view of your risk. And if you can do all that in a way that is easily integrated into your pipelines and enables standards readiness, if you will, by way of producing not only a compliant SBOM structure, but meeting all the minimum requirements and then including all this value add. So regulatory requirements, are essential, and I think globally, between the cybersecurity standards that we have, that everybody, needs to really understand that risk coming from the software supply chain. So one, it's for regulatory reasons or compliance reasons, certainly, at least historically with the Department of Commerce, if you wanted to produce a car and sell a car in the United States, you would need to comply. But even more so, it makes good business sense. Why? Because AI is disrupting the space, and for cybersecurity, and also two, if we want our software to endure long-term, 20 to 25 years, we need to have a really good understanding and visibility and practices built in to ensure you understand that risk coming from the software supply chain. So this is part one of the RunSafe platform. I'm just going to talk about part two next, but the idea here is across your entire software supply chain, a build time, software bill of materials, linking to vulnerability, double checking open source license checks, easily integrating into your pipelines, producing the materials you need, and understanding the origins of that software are really essential to get that right and to understand the risk so your software can endure. Now, the second side of the story from a RunSafe perspective, it's very difficult then when we find severe vulnerabilities or high or critical or high vulnerabilities, what to do about them. And memory safety vulnerabilities are oftentimes critical and high severity vulnerabilities. And so we've taken the approach that it is not feasible in any industry, but including and especially the automotive industry, to easily be able to issue updates and to push out patches, especially in a safety environment, say, with ASIL requirements in 26262 for, different levels of autonomy, that safety requirements necessitate ways to mitigate vulnerabilities. And it's not enough to say, I'll just patch faster. Why? Because AI is producing vulnerabilities faster than you can patch, and it still ignores in the patching process. We still have to do proper testing. We have to do certification for safety systems, and ensure compliance with cyber standards. And so simply patching faster isn't a sufficient enough answer in an AI-driven vuln discovery world. And so our view is the only way to beat AI and work faster than AI is to demonstrate and implement prevention of the exploitation of vulnerabilities before they're even discovered. And so without rewriting source code, without necessarily, or even when patches are not available, and to make memory-based vulnerabilities non-exploitable, our position is that all organizations should insert security that prevents memory-based exploitation at runtime by inserting those protections in the software build process. And that's true for suppliers, it's true for OEMs, that the best approach to mitigate vulnerabilities in an AI-driven world, in a memory safety world, we need to ensure that these vulnerabilities can't be exploited. And that is in part the standard, is to ensure something is not reachable or not exploitable. And so from a RunSafe perspective, we help you with ultimately reachability. Is the vulnerability even accessible in my software? But is it also exploitable? And when RunSafe protections are applied, then they're not exploitable. And that changes the game. That improves operational cost, that improves resilience of systems. It extends the life of legacy software. It ensures higher quality confidence in open source software, and it holds systems to a standard for autonomous driving and for platforms that need to go through safety certification. And so we believe for all of these reasons, identifying risk in a complex software supply chain and then adding in code protection at build time is a great way, not the only way. There's certainly other things that people should want to do, and happy to explore those. There's secure boot. There's reducing the attack surface in general. There's getting rid of code that you don't need. But nonetheless, there will be vulnerabilities in your software. There will be memory safety vulnerabilities, and you're receiving software components from other sources. So with that, the additional step everyone must do to ensure safety, to ensure compliance, to ensure resilience is to add in security at build time and generate a software bill of materials at build time so that you don't put your vehicles at risk once they leave the manufacturing plant. So with that, we feel the most comprehensive defense is to both identify risk in a complex software supply chain and protect code at runtime by doing both of those at the software build layer in your build tool chain. And from a RunSafe perspective, those are very simple integrations. We have integrations that work across architectures in the automotive industry. We support QNX, we support VxWorks, we support Lynx, we support Zephyr and other real-time operating systems. We support many variations of Linux. We support Android. So we support a variety of architectures out there to make it very simple to add us into your software build processes. And if you do that, and you know what's in your software, and you harden it against exploitation, you can reduce risk and stay in compliance. So I would be happy to entertain questions. I know I spoke pretty fast and I kind of blew past a lot of points. And I know we just have a couple minutes remaining. So I'll turn it back and see if in fact there are other questions I can answer.
Thank you very much. That's a wonderful presentation, Joe. We do, in fact, have one question in the chat. We've seen a string of high-profile automotive cyber incidents over the past couple of years. Do you think the industry is taking these seriously enough? And what do you think it's going to take to move from reactive to proactive?
Yeah, we certainly have seen some big headline issues across supply chains in software. We've seen vulnerabilities in running code on vehicles. We've seen supply chains compromised and disrupted. And if I look back on the past, say, 10, 12 years, from where we came from to where we are, 100%, I think the automotive industry takes cybersecurity very, very seriously. I think the automotive industry has done a good job of doing penetration testing. It's done a good job of developing tools to understand risk. There are many forms of compliance regimes out there, from 26262 and, related ASIL safety standards as well, that I think the automotive industry does a very complete job. And with that said, I think, there's still a lot of work to do. I think the reason the Department of Commerce was going down the path of covered vehicles from a supply chain perspective was that it is a complex software supply chain, and there is definitely risk to compromise. And so I also think that the economics of the industry are dramatically changing. Certainly, automotive companies need to focus on consumer experience, differentiation, how their vehicles compare to competition. And so a lot of the focus for automotive needs to be in those value add ways to enhance consumer experience or customer experience. And so my view is you can do a lot from a cybersecurity perspective, adding in security at build time and dramatically reducing risk so that you free up resources to do things in other ways. So now is the time to boost resilience and reduce cost while still taking security seriously so that you can deliver greater innovation, better consumer experience, and more competitive products on the market. So with that, we hope from RunSafe to enable organizations to ultimately be more competitive and more secure.
That's very well said. And thank you very much, Jay. That does bring us right to the end of our presentation time. We want to thank you once more for your time and your expertise today. And I'll encourage everybody online to go ahead and hop on over after the rest of our presentations to the RunSafe virtual booth, where you can see some additional information, check out their content, and feel free to reach out to their staff. If you have any questions or you'd like to connect with them after Partners Week, you can, of course, always reach back out to the Auto-ISAC team, and we're happy to make those connections as well for you. So thanks again once more, Joe, for joining us today.